Greetings and welcome to your recording for week 16. So we are already in week 16. We're getting even closer to the end of the school year. It's also the first week in May, and the last day of school is also in May. So we are currently in the last month of school. So that's pretty exciting, and just wanted to bring that up to let you guys know we are quickly approaching that last day, which is super exciting, but also to get you thinking about your goals for the end of the school year. Where do you want to end the semester, and maybe what kind of grades, or you've got some assignments you want to submit. So thinking about your goals and working towards achieving those goals. So now is the time to put it into gear if you've got some missing assignments and things like that that you want to get submitted before the end of the school year to help your grade out. So we are going to start with our warm-up question to get us thinking about areas, and when we're working with side lengths that might have variables in them. So take a look at this warm-up question where you need to find the area of the rectangle where one side length is given to you as 4x plus 3 and the other side length is 2x plus 2. So think of the formula to find the area of a rectangle and then use those two given side lengths to calculate that. So go ahead and click pause and try this on your own, and then when you're ready to check your work with mine, you know what to do. Go ahead and click play. All right, so how do we find the area of a rectangle? How do we find the area of a rectangle? So there's a couple different formulas that are out there. Oops. And there's, you can find area by doing length times width, or the one that I like to go with is the length of the base times the height. That's the one that I prefer, but if you like length times width, that's okay. It gets us the same answer. So area is base times height. We're going to go with that. Let's actually move to the next slide. I have a whole slide for the warm-up. So let's look at this one. So again, area, we're going to use base times height. And let's move that down. All right, because we're going to plug in and do some algebra here. So we've got the base is 4x plus 3. And we're going to multiply that times the height, which is 2x plus 2. And then we're ready for some algebra. We're going to start distributing. So 4x times 2x is 8x squared. 4x times positive 2 is plus 8x. Then we're going to start distributing the 3. So 3 times 2x gives us positive 6x. 3 times positive 2 is plus 6. Then we're going to use our algebra skills and combine any like terms. The only like terms I see are our middle x terms. So we're going to have 8x squared. When we add 8 plus 6, we get 14. So we're going to add 14x and then plus 6. And that is our area. Remember, area is units of measurement. We use units squared. So since I don't have any units given, I'll just put in there units squared just so that we remember that when we're working with area, we always use units squared. So whether it be centimeter squared, meter squared, it's a part of our answer, and we need to remember that we put in units of measurement as part of our answer. So that gets us thinking about area. And when we look at area, remember, is like all the inside stuff that of a figure. So it's all the inside area, the stuff confined by a two-dimensional shape. So we're going to switch gears this week, and we're going to start looking at three-dimensional figures. Before we do that, we're going to take a quiz that covers sessions 1 through 3. Pretty much focusing on two-dimensional shapes. Then we're going to switch gears. Oh, and we are in Unit 8. I don't know why that says Unit 7. And then we're going to do Unit 8 sessions 4 and 5, switching gears and looking at three-dimensional figures and focusing on finding the volume and surface area of prisms and cylinders. So let's get a head start on what you guys are going to see this week. So looking at volume and surface areas. Again, this week we are focusing only on prisms and cylinders, but guess what? Before the end of the unit, you will find the surface area of all the three-dimensional shapes on this slide, cones, pyramids, and spheres. Those are coming to you, I believe, next week. But this week, we're just focusing on prisms and cylinders. Cylinders, you can see the shape, two base circles. And prisms can be a number of different base shapes. We can have rectangular prisms, we can have triangular prisms, and you'll get a look at what all those look like in just a moment. So prisms, like I said, we can have different types of prisms, and prisms get their names from the shapes they are based on, or think of the bases. So here's a picture of all these different types of prisms. This down here so you guys can see all that. So prisms have two faces that are the same shape. So two faces that are the same shape, those are called like the bases, and that's what we base the name of the prism on. So if you look here, there's a polygon that has 1, 2, 3, 4, 5, 6 sides. There's only two faces that are going to have 6 sides. The rest of the faces are just rectangles. So this would be a 1, 2, 3, 4, 5, 6. 6 sides, a polygon is called what? It's a hexagon, for those of you who need a reminder. So we would call this a hexagonal prism. If you've got your two faces being rectangles, it's a rectangular prism. So just a heads up of how we name them. Again, you're only going to have two faces that are the same, and that's what we base the name on, and then all the other faces are going to be parallelograms. Here's an example of a triangular prism, two faces that are triangles, and the rest are parallelograms. So moving on, learning how to name things are super important. So here's some examples of prisms: a cube or square prism, rectangular prism. Cylinder really is kind of its own, that's kind of its own type of prism. Triangular prism, rectangular prism, pentagonal prism. Gonna move on. So we are going to be looking at surface area and volume this week. So wanted to review what they are. What is surface area and what is volume? So surface area is, think of it as the area on the outside of a prism. So surface area is the material on the outside, where volume is the material on the inside, or the amount of space, I should say. The amount of space on the inside is the volume. So we can describe both the surface and volume with a can of paint. I always say this is take a can of paint, and it's a really easy way to describe both surface area and volume. So if we have a can of paint, the surface area is represented by the material used to make the can. That's the stuff on the outside, the material that makes up the can. That would be our surface area. Whereas the volume is the space in the can. That is the volume. So that's the volume. It would be the paint, the actual paint. The amount of stuff inside the can of paint is the volume. So now that we know all about surface area and volume, we're going to start gathering the vocab of words that we need to know in order to find the surface area. So we're going to start with first, how do we find the surface area of prisms? So in order to find the surface area of prisms, we need to learn this term, lateral area, because we need to find the lateral area in order to eventually find the surface area. So hang out with me for just a second here. So the lateral area of a prism is the area of all the lateral faces. So the lateral faces are all those parallelograms that attach those two specific types of bases. Remember, we just chatted about how every prism will have two specific base shapes, and then all the other faces will be parallelograms. So when we add up the area of all those parallelograms, we're finding the lateral area. We're finding the lateral area. So there's two ways to find lateral area. So one way, it's always fun to have more than one way, right? More than one choice. One way is that you can find the area of one of the lateral faces, so one of those parallelograms, and multiplying by those number of rectangles or parallelograms. So here there's how many different, 1, 2, 3, 4, 5, 6. 6 lateral faces. So if we find the area of one of those lateral faces, so if we just find the area of one of our lateral faces and then multiply it by 6, we've got our lateral area. Or there's a formula that you can use. Lateral area is equal to capital P times H, where capital P is the perimeter of the base. So if we find the perimeter of the base and then multiply it times the height of the entire prism, you'll also get the lateral area. All right, so let's go ahead now and find the lateral area of a rectangular prism. See, my base right here is a rectangle and this base is a rectangle. So it's a rectangular prism. So let's go ahead and practice now with both methods. So we want to find the lateral area of this prism. We're going to do the first method where we find the area of each of our faces, our lateral faces, and then add all those together. So that's our first method. So let's go ahead and focus first on, so we've got a front side and the back that have the same dimensions, right? This front here has a base of 10 and a height of 12. So let's go ahead and find, we'll call this the front. So we've got the area is going to be 10 times 12, which is 120 centimeters squared. But we've also got the back that is the exact same dimensions, right? It's also, if I go ahead and highlight the back, we can see it has the same dimensions. It's got the base of 10 and the height of 12. So the front and the back are going to have the same area. 10 times 12 is also 120 centimeters. Or we could have just multiplied that by 2, but I wanted to point out that those have the same dimensions. I'm going to go ahead and get rid of those highlighting because now we're going to do the left and right side. So I'm going to highlight those differently so that we can, the right and left, we can focus on finding the area of those lateral faces. Let's do that in blue. So we've got the left side and the right side. They have the same dimensions. They have the same dimensions. So left, right. Let's go ahead and do left and right faces. That area is going to be, so the base is going to be 6. And the height is 12. So 6 times 12 is 72 centimeters squared. And we, of course, know the right side has the same dimensions, so it's also going to have 72 centimeters squared. Again, if you just want to find the area of the front face and then multiply that times 2, that's totally fine. And if you want to find the area of the left face and multiply that times 2, depending on how many different lateral sides you have. So now we're going to add all those up to find the total for the lateral area. So I'm going to take 120 plus 120 plus 72 plus 72. So 120 plus 120 plus 72 plus 72, and I get a grand total of 384 centimeters squared. Don't forget our units of measurement, and that is our lateral area. That's our lateral area. That's the first method, right? So now let's see if we like our other method maybe better, maybe it's quicker. Let's try it. Let's see if we get the same answer, which we should. All right, so lateral area, the formula is capital P, which is the perimeter of our base times the height. So let's go ahead. Let's get rid of our highlighting. So here's the base right there, and we want to find the perimeter of our base. So let's go ahead and do that. So the perimeter of our base is going to be, if we just add all the side lengths, so 10 plus 10 plus 6 plus 6. And then what's the height of my prism? 12. So the lateral area is going to be equal to 10 plus 10 is 20 plus 12, that's 32. We'll take, I'm just simplifying here. So 32 times 12, we get dun, dun, dun. This number should look familiar. 384 centimeters squared is the lateral area. So we get the same answer, just two different methods. Whichever one makes more sense to you. I kind of prefer this formula. I think it's a little bit quicker. And then I don't worry that I miss a face, because over here sometimes you might have more than 4 faces. And if you miss finding the area of one of yours, you're not going to have the correct lateral area. So I kind of think the formula is a little bit easier, quicker, and less opportunity to miss a face and then have the wrong lateral area. So that's just the lateral area, right? We need to now work that into finding the surface area of a prism. So let's look at the formula to find the surface area of a prism. It says surface area equals LA. Oh, that's our lateral area. That's why we need to know how to find lateral area. Plus 2 times capital B. So what's capital B? Area of your base. So let's make sure that we understand what all these are. So LA is the lateral area. And remember how we find lateral area? Capital P times H is lateral area. And then capital B is the area of your base. And that might change depending on what type of base you have. You might have a triangle, you might have a rectangle. So the area of the base is going to be, that formula is going to be dependent on what type of base that you have. So surface area we can rewrite as lateral area is capital B times H plus 2 times B. All right, so let's go ahead and find the surface area of this. This is the same prism that we were looking at here. So let's take it a step further and find the actual surface area. So we know the lateral area of this, remember it was 384, right? 384? Yes, 384 centimeters squared. And so we're going to plug that in to our surface area formula. Eventually here we're going to plug that in. But before we do that, what is the capital B? What is the capital B? So that's the area of our base. So what is the area of our base? Let's do math down here really quick. Here's our base right there. So it's going to be 10 times 6, which is 60. So the capital B area of our base is 60 centimeters squared. So let's plug in our values now. We know the lateral area is 384, and we know 2 times capital B, which is 60 centimeters squared. So then let's simplify here. 384 plus 2 times 60, I know, is 120. So now we just are adding together 384 plus 120 is 504, and surface area centimeters squared is going to be our units again. Our units are going to be squared, so it's centimeters squared. And that's it. So not too bad, but understanding what the formulas represent are super important. We can Google any formula, and you guys do have that option of doing that. You've got the internet at the tips of your fingers. So you're able to Google formulas, but what's important, once you get this formula right here, do you know what LA is and do you know what B is? you got to know what those stand for and how to find the lateral area and the area of the base in order to find the surface area. I'm going to go on to the next slide, so if you need more time, go ahead and click pause. So we're actually going to skip this slide of actually finding the lateral area and surface area of a triangular prism, but I just wanted to point out that sometimes, again, finding the area of the base, in this case, is going to require us to find the area of a triangle. So remember that the area of the base, finding that area of the base is dependent upon what kind of shape your base is. And then the lateral area, I recommend you use this formula, but again, there's only 3 faces, so you would have to be really, if you use the other method, make sure that you're finding the area of every single lateral face. But I do want to move on and look at volume before we get to the key phrase assignment. So volume, I think, is a little bit easier than finding surface area. So volume, here's our formula. Do we understand what everything means in it, all the variables? So capital B, again, represents area of the base. That's typically what capital B is going to represent, and then H is the height. So to find the volume of this prism that we already found the surface area of, let's go ahead and do it. So volume equals capital B times H. So let's go ahead and find the capital B. So the area of our base, we've already done that. 10 to find the surface area, we already did that. Let's do it again. So capital B is, we'll substitute in 60. And then the height, this is my height, right, of my prism is 12. So now we're just simply multiplying 60 times 12, and we get 720. My answer is not done though. What am I missing? Units of measurement. So now we're with volume. It's going to be cubed. Our units of measurement are going to be cubed. So remember, surface area, your units of measurement will be squared, where volume, your units will be cubed. So write that down in your math notebook. Don't leave out units of measurement. It is part of your answer, and then know the correct units to use, whether you're working with surface area or with volume. And I think we're going to wrap up there. Oh, you know what? Cylinders, really quick. Let's look at cylinders before we wrap up. So to find volume of cylinders, we're going to use the area of the base times the height. So think of, if we unravel a cylinder, we still have a rectangular lateral face, don't we? And if we unravel it, the length is going to be 2 pi r, which is the circumference of your circle, right? So the circumference, to find the circumference of a circle, it's 2 pi r, which is essentially, if you unravel the circle, that's going to be the length of your lateral face. So to find the volume, it's oops, what did I do? So the reason that I am pointing this stuff out to you is that finding the surface area for cylinders is going to look a little bit different because of the fact that we've got 2 circles for our bases instead of, let's say, triangles or rectangles. So remember to find the surface area. Let's go to the next slide. To find the surface area, we need to calculate the surface area of the top and then the base that goes around the side. So in order to do that, usually, remember, we were finding the area of the perimeter of our base. So same thing is true in a way, but now we're finding the area of our base is a circle. So let's review. Surface area is lateral area times, plus 2 times the area of our base. In this case, the area of our base is going to be the area of a circle. And remember, the area of a circle is pi r squared. So there's the area of our base, pi r squared. And then let's work on the first half of our formula. So lateral area, in this case, height times 2 pi r, because that's the length of our lateral face. Is if we unravel our circle, is the circumference of the circle, right? That's going to be the length of our base, or of the base of our lateral face would be 2 pi r. So lateral area is going to be 2 pi r times height. And that's the surface area of a cylinder. So just wanted to explain where those numbers come from this week when you go to find the lateral area and then the surface area of cylinders. So I'm going to stop now, just give you guys that, and let's go ahead and get our key phrase up here. So one of the formulas we learned this week is for lateral area, LA. And the formula is lateral area equals capital P times H. And I want you to tell me, what does that P, that capital P represent, and what does that lowercase h represent? And that's it. So let me know if you need any help this week. Have a fantastic rest of your week.